electric vehicles, there are certain specifications which will be common, but some of them would be very specific, like recharging time and all. These are very specific to electric vehicles. Yeah. So let us look at this payload capacity. So payload capacity, if it is lower, yeah, your energy efficiency goes up. Yes. However, your load carrying capacity, payload capacity is directly linked to the productivity of the vehicle. So that would go down. Yeah. In terms of cargo capacity, so payload capacity is in terms of mass. That's why the unit is in kilograms. Cargo capacity is thought in more in terms of volume or the passenger capacity. Yeah. So here it is in terms of volume or number of passengers. Again, intuitively you can understand that lower specifications, meaning less capacity to carry the less volume or less number of passengers, you actually need to do more trips. Yeah. Or you actually move people or goods per trip, less number of people or goods per trip. Yeah. Higher specification, you can actually do more trips, sorry, less trips to deliver the same number of goods or passengers. Yeah. On the third parameter, which is energy consumption, we'll go through each one of this in little more detail, understanding how we do from requirement to specification, how we go. Yeah. But right now, just understanding some of these parameters. So energy consumption is basically the unit for unit distance traveled, say 1 kilometer, how much of energy is consumed. Typically water is what we use in electric vehicle, because batteries are rated for watt hour or kilowatt hour. So smaller vehicles will have, starting with two-wheelers around 20 to 30 watt hour per kilometer, cars around 100 to 150 watt hour per kilometer, three-wheelers somewhere between around 50 to 70, 80 watt hour per kilometer. Then you have buses. So mini buses going around 400, 500 watt hour per kilometer. Buses going from around 1 kilowatt hour per kilometer to even up to 2.5 kilowatt hour per kilometer with AC, without AC, and so on. Yeah. So that's kind of the range, and the energy consumption actually also defines. So it's a measure of your efficiency as well, and it also defines for a given battery size how much range you can expect and how much operating expenses you can expect, particularly the energy cost. Then battery capacity. So battery capacity is very specific to electric vehicles, and here higher the battery capacity, you will have a heavier vehicle, but you will have longer range. Although the relationship is not very linear, yeah, because you have to move the mass of the batteries as well. So there is a diminishing returns applied to this. So higher the battery capacity, potentially you can run for higher range, but that range gets reduced because you have to take higher mass of these batteries along as well. So it's usually a trade-off point against how big a battery and how much range that you would want per charge. Yeah. Then battery life. So battery life also requires a certain amount of uh, trade-off, because if you consume the battery life faster, yeah, you can have a smaller battery, but you will consume the battery life faster because you will have to charge it more frequently. And if you have higher battery life, typically those batteries are costlier. They do have slower range degradation as well, but they are costlier. So again, a trade-off or a judgment call has to be made, that how much life do I pay for, while understanding the expectations of the users, how much calendar life they expect out of the batteries. Yeah. Then looking at peak gradability. So peak gradability is basically how much maximum uphill incline the vehicle can climb. Yeah. This is also looked upon in two ways. One is how much incline you can restart the vehicle, meaning vehicle has stopped on a uphill gradient. At how much uphill gradient you can restart the vehicle from zero speed. And the second metric that is looked upon is you are running at certain, say 15-20 kilometers per hour, the vehicle is running, and then it encounters this grade. How much grade can it take before it fails to sustain that 20 kilometers per hour speed? So both of these metrics are looked upon. Depending upon what application we are talking about, one metric may take higher preference over other, but overall these two metrics in terms of gradability are looked upon. And then peak speed is basically the max speed of the vehicle. Again, some applications you won't care about, some application it becomes very important. Some applications you may keep an eye on it, they don't want it to be too low. Particularly in electric vehicles, you tend to have lower max speed because you do not provide multi-speed transmissions. You do not require 4 or 5 speeds, but with a single speed transmission you do away with shifting, and because of that and still a limited range of speeds that the motor can provide, you end up having a less max vehicle speed as compared to its counterpart. So we'll look at some of the sample specification comparisons soon. Yeah. And then finally the recharging time, again very specific to electric vehicles. Here recharging time is the non-productive time. So the more number of hours it takes to recharge the battery, lesser is the availability of the vehicle for productive work.